I'm Nifika.
Hi, I'm Violet Leng.
Hi, I'm Shalini. Hi, I'm Riley.
Hi, I'm Ray.
Now I'm going to present about the introduction. The bus service in UTHM is a stress-free, sustainable, and alternative way for students to travel around the university campus. It is free for students and staff if they show their staff of student ID cards, but is primarily intended for students. In this research, the number of passenger arrivals at FPTP bus stop will be determined and will be analyzed by using both descriptive and inferential statistics. In this research, the bus service in UTHM will be evaluated by defining the number of passenger arrivals at FPTP bus stop. It also highlighted that increasing percentage of student unsatisfied demand on bus service in UTHM is the main problem of the research. Therefore, the study is conducted by collecting numerical data of passenger arrivals in FPTP bus stop to analyze the result through the method of statistics. There are two objectives in this research. First is to determine the number of passenger arrivals at FPTP bus stop in UTHM, and the second is to analyze the data collected by using both descriptive and inferential statistics. This research is to identify the passenger demands and to improve the quality of bus service in UTHM. The scope of study also includes the application of descriptive and inferential statistics on analyzing the results. Besides, it also enhances students' understanding on the application of statistics in real-life setting. Now I'm going to present about the methodology. There are several steps carried out to conduct the research on bus service in UTHM. The problem based on the topic of study have been identified. It was performed by collecting the numerical data for 2 days at FPTP bus stop. It was conducted during the peak hours with the most passenger arrivals at FPTP bus stop. The data was collected from 1:30 p.m. to 3:30 p.m. with duration of 2 hours. The data set was recorded and arranged properly. The method used for analyzing data was identified by using the knowledge learned throughout the course. The data set was analyzing by using both descriptive and inferential statistics. The result was evaluated and the conclusion was met.
Project we carry out at the FPTP bus stop, we consider as a population, which is the group data. Now we create a table which consists of time, number of students, which is the frequency, cumulative frequency, class boundary, class midpoint, fx, f times x squared, and also x minus x bar times f. Next, we total up the frequency with the summation of frequency is 71. The summation of fx is 3380.5, and the summation of fx squared is 206137.75, and lastly is the summation of x minus x bar square f equals to 45183. Proceed to the calculation with mean is x bar equals to summation of fx divided by summation of f is 3380.5 divided by 71 is 47.61. Next is the median. Median is m is equals to lower boundary of class containing the median plus the total number of observation divided by 2 minus the cumulative frequency of the class before the median class divided by the frequency of median class times the size of the median class. Now we sub the value into the formula where the middle of class is summation of f divided by 2 is 71 divided by 2, which we obtain 35.5, which falls between 41 and 50. Next, the median class is 41 to 50. The class is 50.5 minus 40.5 equals to 10, and the frequency is 4 plus 2 plus 14 plus 15 is equals to 35. Next is the frequency of median class is equals to 10, and the lower boundary of class containing the median is 40 plus 41 divided by 2 equals to 40.5. And lastly, the median that we obtain is 41. Proceed to the mode for a group data, where mode is equals to the lower boundary of the class containing the mode plus the difference between the frequency of the mode class and the frequency of the class immediately before it, divided by the difference between the frequency of mode class and the frequency of the class immediately before it, plus difference between the frequency of mode class after it, times the size of the mode class. Now we sub the value where the mode class is 31 to 40. The lower boundary is 31 plus 30 divided by 2 equals to 30.5. The size of the mode class is 40.5 minus 30.5, we get 10. And the D1 is equals to 15 minus 14 equals to 1. D2 equals to 15 minus 10 equals to 5. Thus, we get the final answer for mode is equals to 30.5 plus 10 times 1 divided by 1.5 equals to 32.17.
Now we calculate the variance. The variance formula is sigma square equal to summation of x minus means square times by f, which is frequencies, and divide by summation of frequency, and we get the answer 636.38. And we go to the standard deviation. As we know, the standard deviation is the square root of variance, so we get the answer 25.23. Okay, now we calculate the first quartile. For the formula of first quartile is LK plus in bracket 1 over 4n minus FL over FK times by C. So firstly, we need to find the value of the LK 1 over 4 times by n, FL and FK and C. So when we get the answers, so we substitute the value into the formula, and we get the first quartile is 28.89. We go to the third quartile, Q3. As we know, the difference between the first quartile and third quartile is only the value of 3 over n, 3 over times by n. Just now, first quartile is 1 over 4 times by n. So we just substitute the value into the formula, just change the 3 over 4n, and we get the answer is 68. Next, we calculate the interquartile range. To calculate the interquartile range, from the third quartile minus first quartile, and we get the answer 39.11. Now we go to 25th percentile, P25. So the formula is same with the first and interquartile, just change the k over 100 n. So we get the value 70.75. And for the 25 percentile, we get the answers 28.89, which is same with the first quartile, 28.89. Now we go to the fifth decile, D5. For D5, we just change the value of k, which is 5, and just substitute in the same formula, and we get the answers 41. So it is the same with the median. So 5 decile is equal to median is 41.
Okay, so now I would like to present about simple linear regression and correlation analysis for our project. So to do the analysis, first of all, you need to tabulate the data. So the table is divided into x and y, which is time is as x, number of passenger is as y, and so on. We do the xy calculation, x square calculation, and y square calculation. For the next step, we need to draw a scatter plot to show the relationship between x and y. As from the graph, we can know that this seems to be a negative correlation between time and number of passengers. As the time increases, the numbers of passengers will also decreases. For the next part, we need to determine the coefficient of correlation, which is known as R. For the calculation, we obtain the value R equal to negative 0.4701. The value of R is very close to negative 0.5, so that we can conclude that there is a moderate negative correlation between times and number of passengers. An increase in times will most likely result in decrease in number of passengers. For the next step, we determine the coefficient of determination R squared. From the calculation, we obtain the value R squared equal to 0.2210. This is a portion or a percent, so we can say that there is 22.1% of the variation in the number of passengers is explained by the variation in the time period. For the next step is the regression analysis. We use the equation y prime equal to a plus bx. From the calculation, we get the value b, we get the value a, and we can form an equation y prime equal to negative 0.06399x plus 10.076. That's the equation for us. And for the next, the standard error of the estimate. From the calculation, we get that the xy-axis is equal to 4.543. The standard error expressed 4.543 units above the regression line, which is very small, can be considered as a very small dispersion. Hence, the estimation of the sales is very accurate. And for the last, we do the residual plot. A residual plot is a plot of a residual E against the predicted variable y prime to check the homoscedasticity and linearity assumption made are true or not. So this is the graph that we can plot due to our data. For the conclusion for the graph, we can determine the linearity is true because without trend, randomly spread with no obvious pattern fulfill the requirement. And the homoscedasticity is not true because for the requirement, unbiased have an average value of 0 in any vertical direction doesn't fulfill. And it also doesn't fulfill the spread of the residual should be the same in any vertical direction.
And now I'm going to present about the conclusion. Based on the gathered and analyzed data, by collecting numerical data of passenger arrivals in FPTP bus stop to analyze the result through the method of statistics, with coefficient of correlation R equal to negative 0.5, it can be concluded that there is a moderate negative correlation between time and number of passengers arrival at FPTP bus stop. The residual data obtained from the difference between observed and predicted response variable also concluded that the sample fulfills the requirement of linearity but not homoscedasticity characteristic. With the residual plots were spread randomly without obvious pattern, and the residual are not in the same any direction, making it also did not have an average value of 0. From the descriptive statistic calculated, the result shows that the rate of bus usage in FPTP bus stop is slightly encouraging as there may be lack of bus facility stopping at FPTP bus stop. From this study, the bus schedule stopping at FPTP is able to identify, and thus a suitable time schedule can also be done as a step to provide a better bus transportation system to FPTP students. That's all from us. Thank you.